All right, Intermediate Math 3. It's lesson 2.05, Complex Roots. This is the answers video. So let's go ahead and get started. So this is going to require you to go back and remember some things you did back in Integrated Math 2. And so one of the things we're going to do is we're going to simplify these radical expressions, radical being a square root sign. And the way you do that, what simplifying means is anything that you can pull out of the radical sign, you do it. And anything you can't, you just leave there. So the way you do that is you use something I talked about the other day as a factor tree. So you start with 8 and you break 8 down until you have its prime factors. So 8 can be broken into 4 times 2. 2 is a prime number. Prime number means it's only divisible by 1 and itself. So in the case of 2, it's only divisible by 1 and 2. No other numbers divide evenly into that. 4, though, can be broken down into 2 times 2. So now you can see we have all prime numbers right there. And they would be 2 times 2 times 2. And the idea here, there's an expression I use. It's pair up, pull out. So you pair up any of these that you can. You can take 2 of the 2's and you can pair them up. When you pair those 2's up, 2 times 2 is 4. Now you have a number that's a perfect square. So now you can take the square root of that number 4 and it becomes 2. So what it in effect does is you pair these up and you pull them out of the radical. Now this 2 doesn't have anyone else to pair up with, so it stays inside. So that is the simplified form of the square root of 8. And the way this is read is 2 root 2. That's how you would read that, 2 root 2. Okay, let's do 12. I'll do most of these for you, not all of them. Just be sure you know how to do them. 3 is a prime number, so 12 is 4 times 3. I could have said 2 times 6. It doesn't matter. It'll eventually get you to the prime roots. Okay, I'm going to break that into 2 times 2. And now I have all prime numbers here. So 3 times 2 times 2. Okay, put those inside. So 2 times 2 times 3 is 12, square root of 12. And I pair up those. And you can pull them out. And it's 2 root 3. 3 gets left behind because it can't be paired. How about 10? 10 can be broken down into prime numbers 2 times 5. 2 times 5, but neither of those can be paired. So you can't do anything to simplify it. It's already in simplified form. So you would just leave it as square root of 10. Go ahead and circle the answers here. All right, let's do a few more and then I'll leave the rest. There's 9 in all. How about 100? Well, looking at it, you already know the square root of 100 is 10, but let's go ahead and do it this way. So I have 10 times 10. Okay, 2, 5, 2, 5, those are all prime numbers. Okay. And these 2's here can be paired up. They're not next to each other, but they can still be paired up and pulled out. That brings a 2 out. And these 5's can be paired up and pulled out. So that's times 5. And if you pull all those out, you don't have anything left under the radical there. So it's just 2 times 5 equals 10. So it's just a different way of doing something you already knew. You don't have to do it that way. The square root of 100 is 10. Okay, 24. Pick any 2 numbers you want. 6 times 4, 8 times 3, 12 times 2. Doesn't matter. Let's go with 8 times 3. That's a prime number. 8 is 2 times 4. 2 is a prime number. 4 is 2 times 2. So the prime numbers here at the bottom of the tree are 2 times 2 times 2 times 3. Okay, let me do that over here. Okay, 2 times 2 you can pair up and pull out. So that gives you 2 on the outside. That leaves you with 2 times 3 on the inside. Those 2 can't be paired up. It has to be the same number. So that's 6. So it's 2 root 6. All right. 18. This is the last one, and then you can do the rest for yourself. That doesn't mean you don't have to do the rest of them. It means I want you to do those on your own, okay? Those are the ones I'll check. We can make this 2 times 9, or we could have made it 3 times 6, either one. 2 is prime, 9 is going to be 3 times 3. 2 times 3 times 3. The 3's can be paired up and pulled out. Pull those out, you have a 3 on the outside and a 2 left on the inside, and that is that. Okay? Alright, you just have 3 more to do, finish those up. Okay, in this one, the instruction might not be clear, but it's just meant to illustrate a point of radicals. It says break the following into prime roots. So I don't want you to do what you did above. I don't want you to simplify them. I just want you to show that 10 equals the square root of 2 times the square root of 5. Okay, so you know that. Just so let me just give you an example. Why would you care there? What if I had the square root of 10 over the square root of 5? Then if I knew that I could break the 10 into 2 times 5, root 2, root 5, again, that's the way you would say it, is root 2, root 5, over the root 5, I know that these could cancel and I'd be left with root 2, okay? So that's just an example. You didn't have to do that. Okay, so there's that. How about 12? What would that be? It's 2 times 2 times 3. Okay, 2 times 2 times 3, so it can be broken into that. And 18, we'll just finish them all up here. This is more instruction than it is, checking to see that you know it. Okay, that's going to be 2 root 2 times root 3 times root 3. Again, you want to prime factor it. I'm not asking you to simplify it. So that can be broken into that, okay? All right. Okay, let's move on. So, on the reverse side is some instruction about imaginary and complex numbers. Okay, so the letter I represents the square root of negative 1. So in other words, let's be very clear. I equals this. So anytime you see I, it means that. That is an imaginary number. Why is that an imaginary number? Think about it. There's no number when multiplied by itself equals negative 1. Negative 1 times negative 1 is positive 1. Negative 1 times positive 1 is negative 1. However, that's not a square. Those are two different numbers, negative 1 and positive 1. There is no number that when you multiply it by itself will give you negative 1. So there is no such thing as the square root of negative 1 in the realm of real numbers. And this makes it an imaginary number. Imaginary numbers have applications in science and engineering problems. My training is as an electrical engineer, and in solving electric circuit problems where you have what are called phase-shifted currents and voltages, you can use imaginary numbers in solving the problem. By the end of the problem, you have to have a real number to represent a current or a voltage or something, some other aspect of that circuit. But in the middle, in the intermediate step, in the middle steps, you can be using and do use imaginary numbers and complex numbers. So it's not something that's completely irrelevant. It's actually used in the real world to do things like design cell phones and computers and things like that. Now, if you take the imaginary number, I, that's the square root of negative 1, and square it, then you do get a real number. So the square root of negative 1, the way you inverse or reverse a square root is by squaring it. So if I have the square root of negative 1 and then I square it, the square root of negative 1 times the square root of negative 1, I get negative 1, which is a real number. Okay, so by multiplying two imaginary numbers, you can come out with a real number. Okay, so I squared, another way to write that is I squared, that's the square root of negative 1, is negative 1. That's a real number. Okay, and you can multiply I by real numbers as well. 2i, negative 4i, 0.5i. Okay, so 2i, for example, would be 2 times the square root of negative 1. All right. Now, when you add or subtract a real number and an imaginary number, you get a complex number. So it has a real component, that's a real number, and it has an imaginary component. Real component, imaginary, real component, imaginary. And just by tradition, by convention, you write the real component before the imaginary component. Alright, so now we're going to do some calculations using these down here. The first one is one that you should have memorized, and that is I times I, or I squared. And that's going to be -1 times the square root of -1, right? Times the square root of -1, and that's going to equal -1. So I times I, or that could have also written I squared, will give you -1, a real number. Okay, now how do you do it when you have this situation, okay, or this situation? Let's go to this one. So it's 2 times. So first do the real component first. So 2 times 2 is 4. And then we said that I times I, right here, is -1. So that's 4 times -1. So that equals -4. Okay? This can really get you twisted around in the negative sign, so you have to be very careful with these. Don't try to do them in your head. Okay, 5i times 2i. Okay, so 5 times 2 is 10. And I times I is I squared. And we already said back here, I times I, or I squared, is -1. So this one is going to be 10 times -1 equals -10. Okay, how about this one? So again, when you have an exponent outside of parentheses like that, it just distributes through to everything. So this one is 3 squared times I squared. Okay, it applies to both of those. So 3 squared is 9. I squared is -1. We said that already. And that equals -9. So you're kind of noting a pattern. You just multiply the whole numbers. If you have i's on both numbers, you multiply the real numbers, and then just turn them into a negative. So that went from 10 to -10. This went from 9 to -9. But be careful. Sometimes you only have an I on one of the two factors there. Okay, here's another one. All right. Okay, so this one right here is, let's write it out as a square root of -1. It's negative square root of -1 times square root of -1. So square root of -1, square root of -1 is going to give you -1. And then you're negating one of those. One of those is a negative. That's going to turn it into +1. I'll even put a little plus sign in to emphasize that. It's +1. Okay? So again, it's like a negative times a positive is a negative, but the I times the I is a -1, so that turns it into a +1. All right, these two. So -2 times -5. Remember, when you're multiplying -2 times I, what you're really saying is -2 times I times -5 times I. You have 3 different multiplications there. You can do them in any order. When you have multiplications, you can say 3 times 2 times 4 is the same as 4 times 3 times 2. They're the same. It doesn't matter what order. So same thing here. So you're going to go ahead and choose to do the real numbers first. So -2 times -5 is +10. And I times I is -1. And now you multiply those and you get -10. All right. Again, try to do these on your own. Watching me do them doesn't help you, but I want to do as many for you as I can so that you can see. I'm not doing them for you. I'm doing them to follow up on your attempt and see if you got them right. Okay? So -3 times 4 is -12. I times I is -1. -12, -1 is +12. 6 times 4 is 24. I times I is -1. That's going to equal -24. Again, stop the video, do a few of them, start it up, watch me, see if you did them right. Okay, -6 times -4 is +24, and I times I is -1. That's going to give you -24. Negative 2 times 5 is negative 10. I times I is negative 1. That's going to equal 10. 3 times 5 is 15. I times I is negative 1. Negative 15. And that was a duplicate, so we scrap. Okay. Now, those were all imaginary numbers. Now we're going to multiply some complex numbers, and you FOIL, just like you have in the past. So it's first, outer, inner, and last. So we're going to do 3 times 2 is 6. 3 times I is 3I. 5I times 2 is 10I. And 5I times I, so here you go. This is where you got to do some of this. 5I times I is 5. I times I is negative 1, so it's going to be negative 5. Okay? So it's 5 times effectively a 1 there. You don't see the 1, but it's there. 5 times 1 is 5. I times I is negative 1, so 5 times negative 1 is negative 5. Now, just like when you FOIL, these two middle terms can be added. So it's 3I plus 10I is 13I. And the 6 and the 5 can also be added. So 6 minus 5 is 1 plus 13I. Again, these are both just real numbers, 6 minus 5. You can add them up to get 1. This is 3I plus 10I. It gives you 13I. So there's the answer to that. Okay, let's do this one. Negative 2 times 4 is negative 8. Negative 2 times I is negative 2I. 5I times 4 is 20I. And 5I times I, so it's 5 times, again, it's just like the last one. 5 times 1 is 5, and I times I is negative 1. So that's going to give you negative 5. Negative 8 plus negative 5 is negative 13. And negative 2I plus 20I is going to give you positive 18I. And there's the answer to that. All right. I'm going to do 2 more and then leave the last 2 for you to do. They're no different than the others. 6 times 2. Do the first. 6 times 2 is 12. 6 times 2I is 12I. Negative 3I times 2 is negative 6I. And, okay, here we go. Watch out. Negative 3 times 2 is negative 6. I'm going to put a plus sign here. Negative 6 is negative 3 times 2, and then I times I is negative 1. So I put the plus sign there just to be neutral. So I had a negative 6, and I times I is negative 1. That's positive 6. So it is, in fact, plus 6. If I'd come out with a negative number there, it would have been changed that to a minus sign. So let me go ahead and write everything else down here. And plus 6. So 12 plus 6 is 18. And 12I minus 6I is 6I. Okay, one more here. 1 times 4 is 4. 1 times negative 2I is negative 2I. Negative 5I times 4 is negative 20I. And again, do this, maybe even just go off and do this separately. Come over here and say, I've got to do negative 5I times 2I. Negative 5 times 2 is negative 10. And I times I is negative 1. Negative 10, negative 1 equals positive 10. So now I'm going to come down and write it here. That last one is always going to be one of these, like one of these up here. So go off to the side and do it. Be sure you get it right, and then come down and put the appropriate sign on it. Okay, so 4 plus 10 is 14. And negative 2I minus 20i, it's going to be negative 22i. Alright, and I'm going to leave the last two for you. And I am going to go ahead, I'll just stop this video. So the rest of the problems, there's 5 more kind of big problems to come. I'll put that on a separate video, but be sure you have these concepts down before you go on to those. Okay, I'll see you in the next video.